So here's my attempt to draw a flow chart or something to help you see the relationship between symmetry and even and odd in the tests, all the tests. If you have y-axis symmetry, then xy is on the graph means minus xy is on the graph because you reflect about the y-axis. If you have y-axis symmetry, then you ignore negatives. Also, this thing, xy maps to negative xy, is the same thing as this, right? Because y is f of x. So negative x input gives you the same output, f of x, as when your input is positive. So these say the same thing, but in two different ways. Because remember, you can also write points as x f of x. Negative x f of x. So in goes x, out comes f of x, in goes negative x, out comes f of x, which is exactly what this line says. If you ignore your negatives, you're an even function, and even function, here's your test. All right, for origin symmetry, x and y are negative. So if you write this in function notation, x f of x turns into negative x negative f of x. Which is the same thing this says. In goes negative x, out comes negative x, f of x. In goes negative x, out comes negative f of x. That means that you're keeping the negatives, you're an odd function, and here's your test. So origin symmetry, odd functions, the tests, they're all related, they're all the same thing. It's just whether you're talking about just a graph or if you want to specifically talk about a function, so you're already precluding the idea that there is no x-axis symmetry. And this lets you do a one-step test. If you are this, if plugging in x, negative x gives you f, then you're even. If it gives you negative f, then you're odd. If it doesn't give you either one, then you're neither even nor odd, and you don't have either one of those symmetries.